So the first thing that we need to pay attention to in 1 through 3 is that they're all right triangles. So the definitions for sine, cosine, and tangent do apply here. So sine, remember, is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Those all apply here since they are all right triangles. So the first thing that we have to decide in each of these problems is what combination of sides are we given. So in number 1, we know that this angle is 44 degrees, and I know that this side is x and this side is 5. So x is directly across from 44 degrees. That means it's opposite. And the other side I'm given, 5, I might initially think that this is adjacent, but do pay attention to where it is relative to that right angle. Any side across from a right angle has to be the hypotenuse. So that 5 is the hypotenuse because it's directly across from the right angle. So we've got opposite and hypotenuse. So I'm going to use the definition of sine to help me solve this problem. So sine of 44 degrees equals, this is where I have to use the ratio, opposite over hypotenuse. So I'm going to do x over 5. Since x is my opposite side and 5 is the hypotenuse. So now what I have to do is solve this for x. So you can cross multiply here if you like, but since x is on top, it's probably just as easy to multiply both sides by 5. So x equals, I'll have to use my calculator here, 5 times sine of 44. So it looks like about 3.5. Alright, moving on. Number 2, we're given angle A. We're told it's 47 degrees. And we're also given these two sides. One side is 6, the other side is x. So I do notice right off the bat that one of my sides has to be the hypotenuse since it's right across from the right angle. So we've got at least the hypotenuse that we're working with. But we've also got the other side that's adjacent to that angle. The side labeled x is adjacent. So we're working with adjacent and hypotenuse. So that makes this a problem that's going to use cosine. So let's set up my equation here. Cosine of 47 degrees. And I'm going to use the definition. Cosine of 47 degrees equals adjacent on top, so x, and hypotenuse on bottom, so 6. So cosine of 47 degrees equals x over 6. So similar sort of setup as number 1. So I'm going to solve it the same way. I'm going to multiply both sides by 6. We'll see what x is. So 6 times cosine of 47. So x is about 4.1. And last one in this section, number 3. We're given an angle labeled 43 degrees, and we're given these two sides. One side's labeled 3, the other side's labeled x. So again, the first thing I notice here is that we do have a hypotenuse that we're working with. It's opposite the right angle, so it's definitely the hypotenuse. And just like in the previous one, we also have the adjacent side. 3 is adjacent to that 43-degree angle. So that makes this a cosine problem as well. So cosine of 43 degrees equals, so adjacent goes on top. So 3 in this case, 3 is the adjacent side, and the hypotenuse goes on bottom. The hypotenuse is the side labeled x. So cosine of 43 degrees equals 3 over x. So if you're uncomfortable multiplying both sides by x, this is a case where maybe cross multiplying might be a little bit easier to think about. But just for consistency's sake, I'm going to show you that you can still multiply both sides by what's on bottom. Totally allowable here. So we've got x cosine of 43 degrees equals 3. I do have one more step here. I do need to get x by itself here. So just understand that x is being multiplied by a number. So I need to divide by that number to get x by itself. So I'm going to press alpha y equals here. I've got 3 divided by cosine of 43 degrees. I believe that's right. Yep. So it looks like x is about 4.1.